Hello everyone, in this video we're gonna look at some questions from the homework. So the first one is to find the polynomial function with the real coefficient that has the given degree, zeros, and a solution point. Okay, because we're given that the degree of the polynomial is 4, so I can write the polynomial into an, where an is the leading coefficient, times x minus the first 0 times x minus the second 0 times x minus the third 0 times x minus the fourth 0. Because the degree is 4, so the function gonna have 4 zeros. Some of them they might be real zeros, some of them they might be complex zeros. Okay, and then we're given that the two real zeros are -2 and 1, and we're given one complex zero, which is I. And we said the complex zeros, they always come in pair, in the pair of conjugate. So if I is a 0, then -I is also a 0. So now I can write the function into x minus -2 and x minus 1 times x minus I times x minus -I, which is x plus I. Okay, so right now I have determined all the zeros. The only thing I don't know yet is the coefficient, but I can use the third condition to find the coefficient. The third condition says when x equals 0, the function value is going to be -6. So I plug 0. If I plug 0 into the function, then the right-hand side should be equal to -6. So I'm going to have an times 0 plus 2, 0 minus 1, 0 minus I, 0 plus I. This is going to be equal to -6. So I have 2 times -1, so that's -2, and -I times +I, that is +1. So I have -2 times an equals -6. So an equals +3. Therefore, my answer is 3 times x plus 2 times x minus 1 times x minus I times x plus I. And if we multiply this out, we will get the same answer like this. So x plus 2 times x minus 1, I'll get x squared minus x plus 2x minus 2. And x minus I times x plus I will get x squared plus I times x minus I times x plus 1. So I'll get 3 times x squared plus x minus 2 times x squared plus 1. And then positive ix and negative ix, they are cancelled out. So I'm going to have 3 times x to the 4th plus x squared and x times x squared, so x to the 3rd, x times 1 is x, -2 times x squared minus 2x squared and minus 2. And I combine the x squares. And then I distribute 3 into this polynomial. I will get exactly the same thing. Okay. The second question, use the rational zero test to list the possible rational zeros of f. Verify that the zeros of f shown on the graph are contained in the list. So first, we're going to use the rational zero test to find all the possible zeros. So to do that, I first find the constant. and the leading coefficient. And I consider all the factors of the constants. So the positive, negative 1, positive, negative 3, and positive, negative 7, positive, negative 9, positive, negative positive, negative 21, and positive, negative 63. Okay. Right. Yeah, that's it. And the common factor, all the factors of 2, so the positive 1, positive 2. Okay, so now I can write the list of all the possible zeros. So they are positive, negative 1 divided by positive, negative 1. So we have positive 1, negative 1, and positive, negative 3 divided by positive, negative 1. I have positive 3, negative 3, 7 divided by positive, negative 1, 7, negative 7, and 9, negative 9, 21, negative 21, 63, negative 63. Okay, this time I divided positive 2, negative 2 into these numbers. So I have 1 over 2, negative 1 over 2, 3 over 2, negative 3 over 2, 7 over 2, negative 7 over 2, 9 over 2, negative 9 over 2, 21 over 2, negative 21 over 2, 63 over 2, negative 63 over 2. So if we, okay, well, so here the reason the student got wrong is because positive 9 over 2 is missed. Okay. All right. The third question found on the rational zeros of the function. Okay, the difference between these two questions is for question number 2, we're asked to list all the possible zeros. Now, some of them, they are not the actual zero, but for number 3, we're asked to find what are the actual zeros. Okay, so to find the actual zeros, we first find the list of all possible zeros. So an is negative 6, an equals 1. The factor of negative 6, they are this, okay, and the factor of an, just 1. So the list of the possible zeros are 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. So these are the possible zeros, okay. And to find the real zero, to find the actual zero, now I'm gonna use the synthetic division to test each zero. So 1, because we don't have x squared, so that's 0, and negative 7, negative 6. So if I start with the 1, okay, so 1 times 1, that's 1. 0 plus 1, that's 1. 1 times 1, that's 1. That's negative 6. 1 times negative 6, that's negative 6. Now, the remainder is not 0, so 1 is not a 0. Okay, so next I test negative 1. So negative 1 times 1, that's negative 1. Negative 1 times negative 1, that's positive 1. So the sum is a negative 6. Negative 1 times times negative 6, that's positive 6. Okay, because the remainder is 0, so negative 1 is a 0. Okay, and at this point, we don't have to test the other zeros because the quotient is x squared minus x minus 6. So we solve this equation for 0 then we can find the other zeros. So x squared minus x minus 6, we can factor this into x minus 3 times x plus 2. So the other two zeros are 3 and negative 2. Okay. Right. Because once we found this factor, we are able to factor this polynomial function into x plus 1, because x minus negative 1, so that's x plus 1 times x squared minus x minus 6, right? So there is a 1 0, and there are the other two zeros. Okay, number 4. Okay, again, the degree is 4, so we should have 4 zeros. One is negative 1, the second one is a positive 2, and because we have a square root 2 of I, so the fourth zero gonna be negative square root 2I, because we said the complex zeros, they always come in a pair. So we can write fx into this form, a4, because the degree is 4, so the leading coefficient I write it as a4 times x minus negative 1 times x minus 2 times x minus the square root of I times x minus negative square root of I. Alright, and when x equals 1, it's gonna be 1 plus 1, so 2, 1 minus 2, negative 1, 1 minus square root of 2i, 1 plus square root of 2i, and this should be equal to 24. So here I have negative 2 times a4. Now 1 minus this, 1 minus square root of 2i times 1 plus square root of 2i, we can use the difference of two square formula. So that's 1 square minus square root of 2i square. So that's 1 minus 2i square. And I square is negative 1, so this is 1 plus 2. So that's 3 times negative 2, negative 6a4. So negative 6 times a4 should be equal to 24. Therefore, a4 is negative 4. So the polynomial function fx, we can write it as negative 4 times x plus 1 times x minus 2 times x minus square root of 2i times x plus the square root of 2i. Okay, and if we simplify this result, we should get the same thing. So x plus 1 times x minus 2, so we have x squared minus 2x plus x minus 2. And here we have x squared minus, again, I use the difference of squares, so that's going to be square root of 2 times I squared. So that will be x squared plus 2. So we're going to have x to the 4th plus 2x squared, and a negative x times x squared, negative x to the 3rd minus 2x, negative 2 times x squared minus 2x squared minus 4. These two are cancelled out. And then I distribute negative 4 into this. So I have negative 4x to the 4th plus 4 times x to the 3rd plus 8x plus 16.